Very good afternoon, ladies and gentlemen. Thank you so much for joining our webinar on Autosar Diagnostic Stack. Let's hold on for a couple of minutes. We'll start the webinar at exactly 3:02. Bhishma, can you see the screen?
Of course, yes, Karthik.
Yeah, thanks. Good afternoon once again. I welcome you all to yet another webinar of our on Autosar.
Karthik, we are not able to hear you, Karthik.
Can you hear me?
Yes, yes.
Hello?
Yes, Karthik.
Yeah. Thank you so much for joining us. I welcome you once again for our Autosar Diagnostic Stack webinar. A quick introduction about Ansett. Ansett is a tooling and engineering services company. We've been in the market from 2007, and we've been focusing exclusively on aerospace and the automotive industry. So what we do is we do a lot of things on Autosar product development. In terms of we do custom tool development as well for verification and validation as well as development services. We do a lot of training services and we offer consulting in these services as well, in these areas as well. And myself, I'm Dr. Karthik. I head the research and development wing of Ansett with I have around 16 plus years of experience in both RF and automotive. All right, so that's a quick background about me and the organization. Let's go into the webinar. Today in this webinar, we will be focusing on diagnostics, vehicle diagnostics and diagnostics protocols. So I will start with giving a quick introduction about what is vehicle diagnostics and what are the diagnostic protocols that are available in the market. And then we will move on to Autosar Diagnostic Stack. And I will talk about these 4 modules: the DEM, DCM, FIM, and DET module. I will touch upon all these modules. We will start there, and I will actually try to focus on what are the challenges that we will be facing in terms of configuring the DEM module and DCM module. So from a configurator perspective, there will be some visualization challenges that we will be facing. I will try to focus more on those areas so that we have a clear understanding in terms of developing this module. So that will be the whole objective for today's agenda. So what is vehicle diagnostics? Vehicle diagnostics is all about checking the health of your vehicle using some protocols. All right, so there are different methodologies in which we do vehicle diagnostics. The first is onboard diagnostics, which we primarily say is more focused towards engine emission. And in onboard diagnostics, what we try to do is we find out if there is any error that's happening in the system, and the same is indicated on the dashboard through a malware indication lamp. So that's what we primarily focus on OBD. And in terms of offboard protocols, we have a lot of other protocols like say UDS and other protocols. Okay, so that is a quick background about vehicle diagnostics. and onboard and offboard diagnostics. So when I talk about onboard diagnostics is primarily focused on self-diagnosis, right? So I have some during runtime. So when the engine is running, when the automotive is the car or the automotive is running, whenever there is some error or some failure that has been happening, either in the sensor or actuator, or it could be in the software, the same is logged. Okay, and that is indicated in the dashboard as in the malware indication lamp. So that is what is mainly meant by onboard diagnostics. An extension of onboard diagnostics is excuse me, from the engine emission is we have also expanded to other clusters. Initially onboard diagnostics was focused on exclusively on engine emission, but now we have also extended onboard diagnostics to other clusters, right? Then there is something called as offboard diagnostics, where we use diagnostic devices combined with measurement technology. And what we do is we actually try and log the error. We find out what is the error that is being logged. We try and read some information that is required. We also try and send some data and write some data, and so many other things are being carried out in the offboard diagnostics. So that's a quick background about onboard and offboard diagnostics. So where do we have this requirements? We have these diagnostic requirements at all places, right from the development. So in development, what happens is when we use white box software tests, that means when you are able to see the code and you want to verify if the code is written in a proper way, you use diagnostics at that level. And in the verification and validation level, we use Hill validation, hardware and loop testing, we use diagnostics. And in production level, for integration testing, checking the vehicle condition and all those things we use. And of course, finally on the field, as and when you use the vehicle, if there is some error that is being logged, that is being recorded as an onboard diagnostics. And the next is once you take the vehicle to the mechanic shop, right, a tester is being connected. And the tester will be able to read and log whatever error that is being logged in the system in the car. So all this information will be logged in the car. So this is what is diagnostics all about. And right now, what we will also go is we will just run a small story on how diagnostics is being captured, just as an introduction, so that we have a clear understanding about the whole flow. Okay, so let us assume that there is a sensor in the car, and the car sorry. Let's assume there is a sensor in the car, and the sensor is being tracked by some application software component. And let's assume that there is one fault in the sensor. So maybe there is some VCC supply is not being supplied to the sensor properly. The same will be logged in the same will be captured by the application software component. And once the application software component captures that error, what it does is it will have a film table, and based upon the information, it will pass that information to the film table, and based upon the table data, it will be able to log the error. It will be like, say, each error will have a different type of code, and that code will be logged, and it will be stored in a particular location. It will be stored in the memory. So this is exactly what is happening by logging the error. All right. So this is one part of the diagnostics. So one part of the diagnostics, what we are focusing on is how do we log the error. Like I said, a sensor will have a data sheet, and based on the data sheet, you will actually find out what is the VCC value, what is the error for VCC value, and you will set a particular bit. And the applications, it is the role of it is the responsibility of the application software component to check if there is an error that is being logged. And once the error is being once an error has been detected, that same error, what it will be doing, it will be checked with the table, and you will log the error. So that's one part of the story. The second half of the story starts when now the error has been logged. you have to take the vehicle, once you take the vehicle to a service station, the service station, the engineer actually connects the tester. The tester is a tool. It's a validated tool by the OEM, and once the tester is being connected to the car, the tester will be able to read all the errors that has been logged. So that is the second responsibility of diagnostics. So it is important to break the diagnostics into two parts. Like I said, the first half of it is like say it is responsible. The software component is responsible for capturing the error, identifying what type of error it is, comparing it with the table, and generating a code and storing it in the memory. So that's the first part of it. The second part of it is once the vehicle goes to the diagnostic or service station, it is connected to a tester. Through the tester, we will be able to kind of find out what is the error that is being logged. So this is the second part of the story. So when we talk about protocols like say UDS are protocols which are responsible for the second part of the story. Like say what it is responsible for. UDS stands for Unified Diagnostic Services. So what it is responsible for, it is actually responsible not for capturing the error. UDS is actually responsible for identifying the error code. It is actually identifying the error code. It is called DTC. It is called DTC in UDS terms, but generally it is used for reading the error that is being logged in the memory. So that is the difference. So we will have to differentiate diagnostics into two parts. That's the whole story that I want to say, right? And in terms of a layered architecture, like I mentioned, the application, okay, so the application layer is actually responsible for capturing the error. That means if an error has been logged in either one of the software components in the BSW stack, or it has been logged in an actuator or in a sensor, it is the responsibility of the application software component. In specific, it's called monitor. It is the responsibility of the ASWC monitor to capture the error. That's the first thing, right? Second is it is like say if you want to read the data, you want to read the data. That reading process also will happen through the application software component. That is, someone wants to read the data from the tester. So the tester is the external tool. The tester is connected to the car, and when he wants to read the data, that also is done through the application software component, right? Then there is the transport layer. Okay, so the transport layer, we have the TP. What happens is usually when we want to transmit when the tester is trying to take the data out of the memory from the NVRAM in specific, what happens is the size of the data is not restricted to the CAN byte, a normal CAN byte, which is like say has data of 8 bytes. There is a lot of data that needs to be transmitted. So we use TP, the transport protocol, which is similar to our which is similar to the same application. Which is similar to our OSI model, and here we will be able to capture up to 4096. Okay, 4096 bytes of data you'll be able to transmit. So that is the transport layer, where we have the transport layer is primarily responsible for segmentation and reassembly, because we will not be using a normal CAN packet, which is like say 8 byte. We will be transmitting up to 4096 bytes. So that's a provision that is being provided by the UDS. All right, and in terms of physical, we will be using the underlying protocol. It could be a CAN protocol, or it could be a FlexRay protocol, or whatever it is. UDS will use the underlying protocol to get the data and pass it on, because UDS is primarily an application layer protocol. So we don't worry about what is the underlying protocols. We will be using the underlying protocol, and we will be able to capture it. I will come to this flow a little later, but these are the three layers in which our diagnostics will work. Okay, application, transport, and physical. And like I mentioned, I want to re-emphasize this point. Both the data error capturing as well as data reading, when you take it to the service station, it is the responsibility of the application software component to maintain both these things. All right. So we go to in our session, in this webinar, we will focus our energy exclusively to UDS, and we will be talking about the Autosar Diagnostic Stack exclusively from an UDS and a CAN perspective. So like I mentioned, UDS is an application software component, and it actually uses the underlying protocol. Here in our application, in our webinar, what we will be focusing on is we will be using CAN as our underlying uh, protocol to capture the diagnostics errors. Okay, so this will be the whole storyboard. Some quick introduction, like say UDS has like say 3 or 4 sub-functions. I mean, there are 3 or 4 types of frames. One is a request message with a sub-function ID, and a request message without a sub-function ID, and you have positive response message structures. And we also have negative response frame format. So these are some 4 basic types of UDS frames that are being used to achieve our objective. I'm not going to talk more on this. There's a lot of literature that is available. So we will be focusing exclusively on the Autosar Diagnostic Stack. Like I mentioned, we will be focusing on these 4 modules. The DEM module, which is the Diagnostic Event Manager, and we will be focusing on the Diagnostic Communication Manager, the Functional Inhibition Manager, and the Development Error Tracer. All right, and we will also see what is the role of the NVRAM in diagnostics. So these are some of the things that we will be seeing in this webinar. All right, so we will jump directly into the first module, Diagnostic Event Manager. Like I said, I want to break this flow of diagnostics into 2 parts. The first part is where I say it is we are responsible for capturing if there is any error that has occurred in the sensor, or there is any error that has happened in the BSW module or an actuator. Our first duty is to capture this error. Okay, so that is the first responsibility of diagnostics. So the DEM module, the Diagnostic Event Manager, takes care of this responsibility. So the Diagnostic Event Manager, in association with the application software component, is responsible for capturing the errors that are logged in the that are being logged. Okay, so the errors can be logged for many reasons. Like I said, it could be due to errors in ASWC or BSW or sensor or actuator, but it is this responsibility of the DEM module to log this error. So the DEM is actually present in the services layer. Like in Autosar, there are 3 basic layers. One is the application software component layer. We have an RTE layer, and we have a BSW layer. And in the BSW layer, the Diagnostic Event Manager is sitting in the services layer. All right. And whatever error, whenever there is an error that is being captured captured by the application software component, the application software component will intimate this error to the Diagnostic Event Manager, and that error will be noted down as a DTC. Okay, it's called Diagnostic Trouble Code. Let us say, for example, the error is associated with say, for example, powertrain. If it's a module in the powertrain that has logged this error, okay, there is an error that has occurred in the powertrain, and that error has been identified by the application software component. Then the DTC will look something like this. It's P 00103. Okay, there is a format in which the error has to be logged. It's a very standard format that is specified by ISO 14229 document. All those details are available in that document, and the DTC will be set as per that error. Okay, so each error that, like say for example, if I have a sensor A, and that sensor A has failed because of VCC is not being supplied to it properly. That means if the VCC for that sensor is not between 4.5 volt to 5.5 volt, then that particular sensor for that particular error will have a particular DTC. Okay, so there will be a lot of DTCs, and the DTCs will be specified by the OEM. All these DTCs will be specified by the OEM, and once you have the value, once you find out the type of error, mapping it to the DTC you will be able to log the error. All right. So this is generally the DEM architecture. I want to run you through the DEM architecture so we are very clear in terms of the whole understanding. All right. Like I said, the DEM architecture, it's Diagnostics Event Manager. You have the Diagnostic Event Manager here. Let me just see if I can open. Bhishma, can you see my screen?
Yes, no, Karthik, not it. Karthik, are you able to hear me?
Yeah, I can hear you. I can hear you. I don't know, like, yeah. Can you see it now?
Yes, yes.
Yeah. Sorry. So here we see this is the application layer. This is where all our application software component sits. And this is the runtime environment. The runtime environment is actually responsible for isolating the application software component from the BSW modules. And the below layers is completely the BSW stack. This is your services layer. This the violet color layer is your services layer, and the green guy is your EC abstraction layer, and the orange color is also called the MCAL layer. Okay, so you can refer our previous webinars just in case you are not aware of these names or you are not familiar with these Autosar terminologies. All right, so here your DEM is actually sitting in the system services layer, and if you look at the architecture how it works, all right, an error will let's say for example I will restrict my scope to a sensor being there is a malfunction in the sensor because of VCC not being supplied. So that's an error that's going to happen. If there is no error, the same status will be available in the monitor. Okay, here you have the monitor. The software monitor, what he is doing is he will actually be checking this sensor regularly, and let's assume that everything is working perfectly and it's a 1 byte data that is being transmitted, then all the bits will be 0. Let's assume that's just a use case I'm saying. And the first bit can be turned to 1 if there is a VCC problem. Now this application software component is watching this sensor, and if I find that the VCC is not between 4.5 volt to 5.5 volt, then an error will be logged. Maybe the first bit of that 8 bytes will be turned as 1, and now it detects that there is an error. There is an error. Okay, this error will be indicated to the DEM module. This error will be indicated to the DEM module, and what happens is in the DEM module you will have like say a table which has the database of all the DTCs that will be like say logged, and that will be provided by your CDD file. Okay, so in Autosar the CDD file is also another ARXML file. In our legacy method we call it as a CDD file. So that is our diagnostic file. All those tables will be logged in here. So based on that, the error will be logged. Okay, and that error will be stored in your NVRAM. That error will be stored in your NVRAM. This is the whole flow in which this error logging mechanism happens. Okay, so this is the first step. Like I said, the application software component is responsible for monitoring the sensor, and if there is any error that's been logged in the sensor, the same will be picked up by the application software component. It's here, and that will be passed on to the DEM module, and that DEM module will in turn save that error. It will look into its table and it will log the DTC, and based on that it will be saved in the NVRAM. Okay, so this is the whole process. There is a DCM here, the Diagnostic Communication Manager, and you have your FIM Manager. We are not talking about all these guys at this time being. We are just focusing on how error is being captured. All right. So this is the whole flow. All right. Now I want to move to one more step forward. Like say, how do you define these ports? What are these types of ports? And when you configure in your DaVinci configurator or EBIT resource or any other tool, how will we configure? So that is something that I wanted to also add upon, because this is something it is very confusing, especially when we go configure our DEM module. It is a little bit confusing. So I would like to expand the story into how do we configure in the Autosar module. So that is the next step that we want to do. All right. So how does it happen? Okay, this is the sequence of things that happens that we have talked about. The application software component monitor is responsible for capturing the error, and to avoid intermittent faults, you can also filter it. Okay, and it will be passed on to the DEM. We'll come to all these counters and all those things later. Okay, but in terms of flow, okay, how does this DEM architecture flow happen? Okay, so this is something that I would like to elaborate. All right. The initialization of the event, okay, specific part of the monitor can be triggered by the DEM. All right, so that is the first step. Okay, that means when I say there is an application software component that is being monitored, we know that, or just to be clear, that all these diagnostic events should be triggered based. Okay, this should be triggered based. So what it will do is the DEM is actually responsible for triggering this application software component to go and check this sensor. We have used a sensor as a use case, so I'm just sticking to this use case. Need not be the same. It can be to verify a BSW module also, whatever it is. So the DEM is actually responsible for triggering the event. Maybe it could be a periodic trigger. So every 200 milliseconds, say for instance, the DEM may trigger this application software component to go and check the status of the sensor. So that will be the first step. Okay, that will be the first step. The initialization of the event specific part of the monitor can be triggered by the DEM. All right, can be triggered by the DEM. So that's the first thing. The second step is when once it is being triggered, notification of the DEM about the status change of a diagnostic event is done by the software component monitor. Okay, so once this trigger has been initialized by the DEM, the software component monitor will, like, say, look at the sensor, and it will indicate the status, and it will, like, say, set the status of the diagnostic event. It will set the status of the diagnostic event, period. So that is the second step. The third is the DEM module will actually go and read what is the status. It will actually read the status, and then if there is I'm sorry. Okay, like I said, there is already, like, say, the DEM module has got the table, and he will go and check the status with the existing status of the table. Okay, is it, like, say, what it has to be programmed? If there is some difference, then the DEM module will understand that there is an error that has been logged, and it will set a DTC. All right, so that's the third step. And the last step is, if there is, like, say, an indicator option available, there is, like, say, there is a specific component that you need a particular indication through a lamp or whatever it is, then you could also, like, say, indicate it through your indication event. All right. So this is the whole flow that I'm talking about. Okay, I'm just talking about this guy, the DEM module, and you have the monitor, the application software component module here. All right, so you will find that the DEM module is the guy who will go and trigger the application software component. Not necessarily always. All right, in our use case, I'm considering a DEM module to be, like, say, triggering. Okay, so this will be the client port. Please listen. See, this is the client port I've did. If you understand this, there are, like, say, you could refer our previous webinars on client server as well, especially the application software module. This is a client server module. All service requests will happen only through client server interface. It will not happen through RTE interface. So this is a service request. This is primarily a service request sitting in the services module, the DEM module. So the DEM is actually triggering an event. He's asking this application software component to go and check the status of the sensor, and this application software component monitor will, like, say, reflect the status. The DEM will read the status, and if it will compare with the table, and if there is any error that is being logged, that will be noted, and it will be stored in the NVRAM. So this is the flow in which it happens. All right, step one. Now if you look at what type of ports that you have to choose, there are two things that we need to remember. One is that like I mentioned, it is always the client-server interface. When we talk about an interface, it's always a client-server interface between services port. So naturally, when you are configuring in your DaVinci configurator, you will have to choose a client-server interface. That's the first step that we need to do. It has to be so this is a client server port. That is the first thing that it has to be done, and it should be a services port. Okay, so there is a particular type of port where we call it as a services port. We will have to choose a services port to configure it because it is a service module, and we'll need to choose a service port. That's the second thing that we need to remember. Third, what we need to remember is when we configure is this trigger, since it is being set by the DEM module here. Okay, so the DEM is actually responsible for triggering the event. Okay, the DEM is responsible for triggering the event. So the request actually comes from the DEM module. So that is why I put the client side here and you have the server here. So the server will pick up this request. The application monitor will pick up the request, and what request it is doing, it will actually go and check the status of the sensor and load it with and give the status information to the DEM module. So this is a client server request. Now, like I mentioned earlier, the request need not always be triggered by the DEM module. It can also be triggered by the application software component. All right, so it can also be triggered by the application software component. If the request is actually triggered by the application software component, then you will actually configure this application software component as client and your DEM module as your server. But in both the cases, it has to be a services port. It has to be a services port. All right. So irrespective of the configurator, whether we are using a DaVinci configurator or EB Trezors or ETAS tool, this is the procedure that we will have to follow. All right. And then we talked about the other option. We also have, like, say, applications software component, which could act as an indicator, like it could be a malware indication lamp. All right, if the DEM module is configured, you could also trigger read this data from the, or you can request this data from DEM, and it could be, like, say, displayed in the application software component. Again, usually if you actually look in terms of an application software component development, you will find that whenever you want to, like, say, do when you want to trigger a telltale or you want to trigger a telltale, we usually use a sender receiver interface. But now you'll find that we are using a client server interface, primarily because like I mentioned, all services will happen only through client server interface. All services will have a services port will happen through client server interfaces. All right. So this is a standardized interface. All right. So a services port. All right. So going forward, this is a very important point. I thought, like, I also wanted to add one more civet. If you are configuring the DEM module, I would strongly recommend we read chapter 11 of the Autosar DEM document. Because it is in this Autosar chapter 11 document, chapter 11 only, we have all these details on how to configure the ports and port interfaces for DEM. All those things are added as a separate chapter in DEM document. I would strongly recommend we read that particular chapter before we start configuring the in the tool. Okay, so that's a quick add-on that I wanted to mention. So each software component which uses the service must contain a service port. Like I mentioned, it will be configured through the service port. And in the software component description, you'll have to choose a service port when you add the ports in the software component description, right? And you will also add the interface, correct? And you will also add the interface. and the same interface will be connected through the DEM. Okay, so once you connect it, we will be able to generate the RTE. This is something similar to any other stack. Even in our IO stack, we do the same thing. Like we add the corresponding port and we map it to the right interface. And once we map it to the right interface, the RTE gets generated. This is the same thing. The civet is that we have to be clear in terms of where do you want to configure, whether you want to configure it as a client or as a server, the application service port, whether you want to configure it as a client or a server. Usually what happens is, if you want to read some data, like say for example the DCM wants to read the data, I'll come to it later. When you want to, like say, read some data from the DEM, you'll use the trigger from the application software component. But when you want to log the data, you usually use the trigger from the DEM. That's something that is used as a standard procedure in many of the OEMs. All right. And one other important thing that we have to be very clear is, one port of this interface must be provided for every event ID. Okay, so each and every event ID will have a separate diagnostic monitor interface. All right, so that you can actually modify and obtain this information, this event information, through this diagnostic monitor interface. And like I mentioned, once again, each and every event should have an independent interface. It should have an independent diagnostic monitor interface. Okay, so this is something that we need to take care of. Okay, so this is how this is a kind of a pseudocode that exists between the DEM and the software component. This is for our use case that we have discussed. Like I said, we have a client server interface and we have this diagnostic monitor. All right, and this diagnostic monitor is configured for this interface is for this particular event. We will have to limit this discussion only to this particular event. And so the first step is, like say, the DEM is asking for some data. He's asking the client for, he's asking the application software component about the status of the sensor, and the application software components provides it with the data, whether it is the event has failed or whatever it has been done. And the same will be, like say, the DTC, the same will be read by the DEM. It will be read by the DEM. Information is passed to the DEM event, and once that information is available in the DEM event, it will set a DTC. And once the DTC is set, it will also, like say, capture the freeze frame. Freeze frame is nothing but it's an optional thing. Freeze frame is, like say, when you capture some error, we would also capture some other, we would also, like say, like to capture some other information, like say, what is the odometer value at that point of a time, what is the speed, what is the window status, was it, like say, down or up, whatever it is. There are so many other information that may be relevant to that particular sensor to which it is working. So we may like to capture all these details so that we have a clear understanding of the reason for which the error has occurred. So this is what we call it as a freeze frame. The same will be captured by the application software component, and it will be picked up by the DEM, and it will be stored in the NVRAM. Then we also mentioned these are, like say, similar to any diagnostic module. We also, like say, the DEM will also have this counter, fault detection counter. Our main objective is to make sure that we clear the error in the NVRAM, because we have a very limited NVRAM space. Like, in the memory architecture, if we understand, a portion of the flash memory is actually allocated as an NVRAM for storing all this data, because if we add an external EEPROM, then it becomes very costly. So we will only create a portion of this flash to be allocated as an NVRAM. So our objective is also to make sure that if it is caused due to some intermittent fault, which can be rectified over a period of time, it has to be over a period of time removed from the NVRAM. So the DEM also has many debouncing techniques. Debouncing techniques are techniques which are used to identify errors, and if there are counters are set, and if the error is not logged for, if it is logged once, and then again and again when it is checking, like say for example, again and again when the DEM is checking and this error has not occurred concurrently or recursively, then the same error will be removed uh, from the NVRAM. So that is why we have this fault detection counter that's also being taken care. And if it is like say done, it will be removed over a period of time. Okay, so this is triggered as an event. Like I said, it will be triggered as an event through the client server interface, and over a period of time all these errors will be logged. Okay, so this is the whole flow. This is how it will look like. Just to give you a quick, it's the same picture that we have seen in the previous slide. Just stopping for one moment. Like I said, like here we have the DEM module. We have the DEM module here, and here you have another software component. Primarily, it is the responsibility of the software component to capture the error, okay, and inform the DEM module. All right. Many times it is actually misinterpreted that the DEM module is will capture the error, and it will be like say, excuse me. Yeah, so a DEM module will capture the error. The DEM module actually does not capture the error. It is the responsibility of the application software component monitor to capture the error, and the DEM module only logs the error. Okay, so this is something that we will all have to take care of. All right, so there are some UDS service numbers. These are typically available in the ISO document. Service number 19 is completely related to DEM module. So it is used to check, okay, it is used to capture some data from the DEM module. So the DCM will use this particular ID to read the data from the DEM module. Okay, so this is something. I just want to say this point that UDS service number 19 is completely related to the DEM module. Okay, so I will stop the discussion here, and we will extend the discussion on further details when we come to the DCM module. But as of now, UDS service number 19 is related to the DEM module. All right. So the DEM module has all these primary tasks. Like I said, capturing, logging the DTC. It has to organize store the DTC in the NVRAM and organize it. And if there is some snapshot data or freeze frame, that also has to be captured. Some extended records have to be captured and stored, and provide for unlearning of errors. Like I say, whenever there is an error that's repeated over, I mean, it has to be removed from the NVRAM. It also has to take care of that, and it provides an interface. Okay, so this is where we start the DCM. So it provides an interface for error readout for the DCM. It now provides an error readout for the DCM. Okay, so when we talk about DEM, I'm talking about the first half of the story that we have always been talking about. It is responsible for capturing the error in runtime. So all these things that we were talking about, capturing the error, logging it in the NVRAM, all these things were happening in the runtime. All right, so this is when the vehicle is running. Now we move to the second half of the story. The second half of the story is the diagnostic communication manager. So in your diagnostic communication manager, what we do is the diagnostic communication manager is responsible for reading the errors from the NVRAM through the, reading the errors from the NVRAM. So that is the responsibility of the diagnostic communication manager. So where does the diagnostic communication manager actually start? The role of the diagnostic communication manager actually starts after the vehicle is taken to the service station. So in the service station, you have a tester. Okay, I'm sorry, I don't have that. Anyway, so yeah, in the service station, you have the tester. The tester will be connected to this to the vehicle, and typically through the CAN bus. Typically through the CAN bus, what happens is the tester acts as a client, and your ECU will be acting as a server. Like there are two types of functional data sets, and there is also something called as a physical addressing modes. There are two types of addressing. So based on that, what happens is your tester will request, this signal is actually passed through the CAN bus. That means your tester is nothing but a diagnostic tool which is available in the service station. So the service guy will connect this tester to the CAN bus, and through the CAN bus he will be reading the data from the ECU. So when I say reading the data from the ECU, what does the data? It is one of the data is error. Let's now limit our discussion only to error. Okay, so excuse me. Only to error. There are other things that your DCM can do, like say it can read data, it can write data, and all those things. We are not focused on that. Let's just limit our discussion to it wants to read the error that has been logged by the DEM module. Now what it happens to do, let's just focus on that flow. It will use this particular service ID. We talked about it. The ISO service number 19, that number is used exclusively for the DEM module. So it goes like this. Yeah, see here it is. The data will be like, say, now the data will be actually not the data, the request from the tester. The tester is the client. This is your server. This is the whole server. The server is your the server is the guy who is going to respond to this request. All right. So the data has to go from the client to the server through the CAN bus. Here we are saying like say CAN bus because in the beginning of the webinar I said we will be restricting our focus to the CAN bus. So that is why I'm saying CAN bus. UDS is a protocol independent guy, so we can use any other bus. We can use a most bus, we can use the flex array, whatever it is. We can like say use different types of buses. That is not a problem. Here we are using our CAN bus, so it is connected to our CAN bus, and through the CAN bus the signal comes. Okay, the service ID comes as a CAN message, and it touches the microcontroller, and it goes through the driver. The driver validates it. You through the CAN IS, through the bus TP, it reaches the PDR, and in the PDR, you remember that could actually send it to the diagnostic communication manager, or it could send it to the COM module. Okay, so it could send. Now you know that this guy is the PDR on reading the CAN frame. He knows that it has to be routed to the diagnostic communication manager. So the data actually reaches the DCM. Okay, so the data actually reaches the DCM. Okay, so if I have to answer this question, how does this request, I'm not talking about the structure of the request and all those things. They are all available in the UDS document. You can refer in various locations. But the objective that I am trying to say here is, how does the request reach the diagnostic communication manager? So the flow of the request comes through the CAN bus, because here we have connected the tester. The tester is connected to the CAN bus. The CAN bus, through the CAN bus, the tester is sending a service ID, service request, I will call it the service request. This service request comes as a CAN message. It has an ID. The ID is 19. The ID is 19. I19 means it's primarily to get the data from the DEM module. Okay, so this ID comes, and through the communication port. Actually, it's through the COM stack. If you remember, you can refer our COM stack webinar. It is through the COM stack. It actually reaches the DCM. Even if in your communication module, the flow remains the same. It goes to the CAN bus, flows through the PDR or bus, whatever it is, the same story. Since we are using a CAN bus, it will be like the same story. It reaches the DCM. That's the first part of it. Now the signal has reached the DCM. Now the DCM knows that now I have some request. Okay, and I need to serve this request. All right. So before I go into like say how this request is being served, I would again go back to our this slide. I'm sorry, I'm just switching. I want to go back to this slide and actually talk about how this request will be served. Okay, how this request will be served. Okay, actually, I think there is some error here. Okay, I mean, it's taken from the DCM module only. All right, let's listen. Now this request, like say from the microcontroller, it has reached the DCM module. It has actually reached the DCM module. Okay, now the DCL module can now read there are 3 layers in the DCM module. We will talk about the 3 layers in a moment. But now once the request reaches the DCM module, the next step is that the DCM and the ASWC has to be connected. Okay, the DCM understands that it needs to read some data from the DEM module. It needs to read some data from the DEM module. It will not actually ping the DEM module directly and ask him what is the data that I want to read. That may not happen. Okay, so what it will do is it will actually reach out to the application software component. It will actually reach out to the application software component, and you will create one service port. You will create one service port between the DCM module and your application software component, just like what you created for your DEM module. Similarly, you will create, and once you create that port, what happens is you will have it will again be a client server interface. The interface will be a client server interface, and it will again be a services port. It will be again a services port. But here what the difference could be is like, say for example, yeah, it could be a services port. It will be connected to the DCM. Okay, and here now the objective of this guy, this particular monitor, is to get, so the DCM is asking for some information. This information will be captured from the DEM, right? So he's creating another port in the DEM. He's creating another port in the DEM. Here what happens is this port could be the other way around. Okay, I will keep the client here and the server here, because now the request is actually triggered by the application software component. Now the request is actually triggered by the application software component. The application software component is going to request for some data in the DEM. That request is coming to the DEM module, and that request is the 19 service ID. So you will ask for what is the error that's being logged, and you know that each event has a different set of IDs. So based on this ID, he will actually identify what is the error code that has happened. It will log the error, and that error will be passed through the application software component to the DCM. So this is the flow in which this whole transaction happens. So the DCM will request the application software component through the service port of that he wants this data, and that will be triggered through the DEM, and the DEM will capture this error. And I'm sorry. I'm sorry. I think I lost. Just give me one moment. Bhishma, can you see the screen? Sorry.
Yes, Karthik, it's visible.
Yeah. So through the error will be captured, and the same will be passed through the DCM. So this is the whole flow in which it happens. Okay, just to give you a flow, because it's important we know this flow to configure the stack. Yeah. All right. So here, for lack of time, I will run you fast. Okay. So the whole story comes like this. The session comes to the DCM module. This is primarily a DCM module. The DCM module has 3 independent modules. One is the DSL module, Diagnostic Session layer. Then we have the Diagnostic Service Dispatcher, and then we have finally the Diagnostic Service Processor. These are the 3 modules that are available in your DCM. There are not many things that needs to be configured here. The first thing, so I will run it fast. So first is the Diagnostic Session layer. So the primary responsibility of the Diagnostic Session layer is something similar to our session layer in OSI interface of which we use in networking. So his responsibility is to establish a session. Okay. So the whole responsibility, when I mean by a session, is there is a particular service request that comes to the Diagnostic Communication Manager. He needs to serve this request. So a separate session, a separate a container or buffer, okay, is created for this session. A separate an exclusive area is created for this session, so that this session is not being interfered by other sessions. That is the main objective of the session layer. So in terms of configuration, in the DSL, you will probably configure the buffer, what is the size of the buffer that you want to configure, and all those things. So the basic things that will be configured in the DSL module. Okay. The second important fellow is the Diagnostic diagnostic services dispatcher. This diagnostic services dispatcher has got all the NRC codes. All right, so it has got the entire list of NRC codes. So as and when, like say for example, you ask for 0x13. Let us assume that one of the services is 0x13. I assume that there is no service ID with that address type, address number 0x13, right? So what happens is, once this establishes a session, it will be forwarded to the DSD, and the DSD will run the NRC. NRC is non-responsive codes. Like say there are like, I'm not sure about the exact numbers. Let's assume that there are like say 15 NRC codes. So it will check each of these NRCs is satisfied. If any of these NRCs is satisfied, that means it will respond with a negative response code. Say for our instance, I have given 0x13. Now, as and when it is running in a sequential manner, it comes to a place where there is an NRC which says that this ID is not available. It's not a valid service ID. Then the DST module will respond with a negative it will respond with a negative response code. So that is the objective of the DST module. Other than that, what it will also do is it will check, it will, if it is if it is a valid ID, it will pass this information to the DSP, which is your diagnostic service processor, and any information from the diagnostic services processor will be routed back to the DSL through the DST. That also is taken care by the DST. So this is something the DST will do. It's more of a dispatcher of negative and positive response code. It will also, like say for example, there are some specific use cases where you have to send a positive response code, but you want to suppress it, or you want to send a negative response code on certain conditions, you want to suppress it. All those things will be taken care in the DST module. All right. So the next layer is your DSP module. So in the DSP module, when we go to the DSP module, the data is now after successfully passing, it is now gone to the DSP module. Now, once it reaches the DSP module, it understands what this service ID is asking for. Now, let us say, for example, it is a 19 service. That means it has to request for the DEM and get some data from the DEM. Right now, it will pass this data to the application software component, capture the data, error data, and in turn send it back to the tester. So that is the responsibility of the diagnostic service processor, which finally decides based on the service what type of service has to be offered, and it will forward this request to that particular module. It could be a BSW module, or it could be an application software component module. So it will forward it to that particular module, and based on that it will get the data, and it will forward it back to the DST, which will in turn go to the DSL, and through the PDR and the COM stack, it will actually reach the tester. Okay, so the tester is configured. So that is something it will do. The next is the development error tracer. Okay, so what is a development error tracer? The development error tracer is actually a module which is used for during development purposes. Let us say, for example, I want to update some data in the ECU, right? So I connect my tester, and then through the tester, you want to send some data to update the application software component. You are updating this application, and as and when this updation has happened, let us say there is some kind of an error that is being logged. All those things will be captured in the DET. Okay, so the bootloader, before it actually goes to the flash, it will see if there is any update in the flash. Any update has to be done in the application code. It will do this application and then start the execution. Okay, so the DET is primarily focused more towards development. It does not have more requirements after implementation or during runtime. The DEM module and the DCM module are two modules which are responsible for diagnostics. Like I said, DEM is capturing error during runtime, and the DCM is you take it to the service station and you want to capture what type of error, or you want to do some kind of transaction with the ECU. That's when you use the DCM. Okay, and DET module is primarily, like say I said, focused more towards this is used when during the time of development. I will say it is used during the time of development. It does not have much significance during runtime. All right. So we have seen these three modules. and the DEM module, DCM module, and the DET module in this webinar. And what we have also seen is the flow. Like say, I want to break it into two flows. One is like say capturing the error, which is your DEM module, and the other one is like say reading the error, which happens through your DCM module. So I wanted to break this into two parts. And the third is the configuration. When I said configuration, how do you configure the ports in the diagnostic modules? Okay, and one like say especially in the DEM module, if one other tip that I want to add is, please do read chapter 11 of your DEM module in the Autosar document before you configure. It has a very clear representation of how the ports have to be configured for the DEM module. So that's in a nutshell. So thank you so much for your time. Thank you so much for listening. It's been wonderful again hosting a webinar for you. I'm open. Let's take up any questions if we have. Thank you once again for your time.
Thanks, Karthik, for the session.
Yeah. Okay. Okay. There's a first question. Okay, the question is, can you send 4 bytes of data? You can actually send 4 bytes of data, but you don't need a CAN TP for that. You will use a CAN TP only when you want to transmit over 8 bytes. So that is where you will use a CAN TP. We are adding SID plus 40. Why can't we add some other value plus 40? Okay, so there is a service identifier. There is a range in which the service identifiers have to be listed. Okay, so that is all defined by ISO document. Whenever you want to send a positive response, okay, that is, let us say for example, you are transmitting a service ID some like say 19. Let's say for example 19. All right, so hexadecimal 19. All right, so what you will do is you will go and like I said, it will check all the DS. It will reach the DCM. In the DCM, it will pass the DSL and it will go to the DST module. There it will run the list of negative response codes. And if it clears all the negative response codes, then what it will do is it will understand it's a positive response. So it will give a positive response. So a positive response is added with plus 40. So service ID plus 40. It's an ISO standard. There is no specific reason. It's an ISO standard, and we follow that standard. So the tester, when it receives a response with plus 40, then it as a service ID, it knows it's a positive response. If it is getting 7F, then it knows it's a negative response. Yeah. Okay. It will be available in YouTube. You can pick it up. Okay. The contest is taken. Okay, I think Shruti, it's a very interesting question that you have, but I don't think we can take this question. I want to like say spend more time on it. If you could write a mail to us, I'll be more than happy to kind of explain how this context is, or we can take it on a one-to-one. That's for Shruti's question on ASIL and multi-cores, like say 2 different cores. The OS also has to be manufactured. It's a very interesting question. I would definitely like to take that. Yeah, on offline. What is okay? Okay, there are a lot of questions. I think I will write. Bhishma, can you just make a note of all these questions? We will try to answer all these questions.
Yes, Karthik, I am collecting all the questions. We will post in our LinkedIn.
We will write to all these questions in like say a day or two. We can actually add all these questions as in the YouTube itself. We can add these questions as questions and answer them. We'll do that. Okay. Okay. Okay, physical. There are a lot of interesting questions. Okay, I'll just try and take a few questions. One is physical addressing and functional addressing is a pretty straightforward thing. Like say, for example, a tester, if he knows for this ECU only, I want to take this question, then I want to take a question, he will use the physical address. You can use the physical address, and it will be addressed to that issue. That CAN message will be addressed to the issue. It will be a broadcast message, but it will be addressed to that issue will know it is for me, and it will pick it up, right? In functional addressing, it will go through the gateway unit. So the entire cluster will pick up this data, and what happens is it will read the data, and many of these issues will know that it is not for me, and it will give it will not respond with an NRC. Actually, it will not respond with an NRC, but it will actually take it, and it will be addressed to the entire cluster. So that is what is called by functional addressing. Okay. There are some few interview questions. I don't have interview questions, but if you have any questions, you write to me. I can do it. Bishpa, can you just share your mail ID? We would love to reply to all these questions on mail.
Sure, Karthik.
Yeah. And the film in diagnostics, if you want to, like, say, for example, there is an event, there is an error that is being logged. It could be, like, say, one particular event that is being logged as an error. But if you want to stop the whole function, you want to inhibit the whole function, then you will use a film manager. You will configure the film manager in such a way that on such and such conditions, you stop this function. So the ECU will actually stop executing the function. That is what will happen in the film manager. Yeah, then okay, when DTC will get stored in NVM at the time of test failed bit set or at the time of confirmed bit set. It will actually, like, say, store at the confirmed bit set only. Okay, so what happens is that is where it will actually go and store it as a confirmed bit set. That's to Karthik's question. Yeah. So there are actually two types of thing. There is a pending DTC and there is a confirmed DTC. So first, when you, like, say, log and DTC, it will be stored as a pending DTC, and based upon the type of DTC, you will set a counter, and you will execute this counter. And let us say, for example, 5 times. Let's say I will check this DTC value 5 times, and if this 5 times the DTC value is still remaining, then I will, like, say, log it. I will move it to a confirmed DTC and store it in the NVRAM. Or there could be a place where I will, like, say, log it 5 times, and for 5 ignition on and off, for 5 ignition on and off, I'm just giving a random number, 5 ignition on and off, if the DTC does not happen, then you can probably reset it. So that could be like the pending DTC is removed from the NVRAM. So that is something that will happen. So there are two types of the pending and confirmed. Okay, is custom implementation to be done in ASWC for 19 UDS request, like reading respective details from until by custom requests have to be done. Yeah, it has to be done. Okay, so you will have to use the ASWC and configure it with your DEM to read the data. Otherwise, it will not be able to do it. So that's for Shaik's question. Det, like I mentioned, it is used for application development, error detection during application development. Okay, during the development times. Apart from, okay, there are a lot of BSW modules errors. I can actually write to you. We have a list also. We can just share that list with you as well. Time of test fail. Okay, I think that same question. Okay, the sensor example is it's a pretty straightforward practical example. Okay, what does this practical example mean? I don't understand. I think that was a pretty straightforward practical example. I said for error logging, you will have a data sheet. That data sheet will have, like, say, the error reporting mechanism, and all those things will be done. Okay. Okay, this, like, quite a lot of questions. Oh my God, this. I will write to all these questions. It's very important. We will write to all of you, and yeah, for lack of time, we will do that. When reading DTC, can you share to all questions on WhatsApp group? Oh, all of us, or all of us mail ID. How do we receive? How will we respond, Bhishma?
Regarding Karthik, their queries,
Regarding the queries, yeah.
they will drop their queries to our mail ID. We will respond to them.
No, these are some queries that they have directly. So if I want to respond to them,
Which one, Karthik, you are speaking about?
there is a list of queries that are thrown on the slide. How do we respond to them?
That one we need to again present in a YouTube channel or something like that only.
Okay, okay,
Because we don't have the participants' exact email ID in this Zoom.
okay, okay. All right. Yeah. Okay. Okay. One question that are like say available is BSW errors. Okay. There are actually there are like say 5 or 6 types of errors. All right. There are like say development errors. There are like say runtime errors, transient errors. And there are so many other types of errors. Okay, so you can actually classify the error into different types and do it. So that is the type of errors that I will log it. Okay, yeah, that's one other question. I've lost the this thing. What do you call? Can you see the screen?
No, we didn't.
I'm not able to see the questions. Oh, here it is. Okay, here it is. Okay. That's one BSW error reporting BSW. That's what is Harish. That's to answer Harish question. Okay. Vector module communicates with the. Okay. See, you should. There are only 3 Krishnacharya Chilakani. Okay, so there are only 3 types of interfaces. It will actually like say use dem module communicates with the NVRAM through a standardized interface. Okay. Sorry, it will communicate with the NVRAM through a standardized Autosar interface. It will be a standardized Autosar interface. That's okay. Fault is active. Which bits to be considered in Canoe? That depends upon. I'm not able to actually take that question. Which bits to be considered in Canoe? I actually am not able to understand the question. Okay, I will save all these questions and we will put it as answers and we will share it with you. Like say we will for all those people who have registered in the webinar, we will share those question and answers to all those people. I think that will be an easy way, isn't it, Bhishma? That will be an easy thing, right?
Yes, Karthik, we can send you a common mail.
Yeah, we can send a common mail. Can we just capture these questions alone if you don't mind?
Yeah, we have it, Karthik.
We have already captured these questions, right? Yes. Super. We will do that. Thank you so much, guys. Thank you so much for joining. If there are any questions on, like, say, you want, like, say, online, we can take those questions. Okay. I will, we'll revert to you maybe by end of the day or by tomorrow. We will reply to all your questions. Thank you so much for joining us. It's a pleasure hosting all of you. We look forward to host you in our next webinar. The next webinar will be on Lin and the Lin stack. We will be hosting it on the first Thursday of every month. Unfortunately, this week we couldn't do it primarily because there were some I was sick. Okay, to be straightforward, I was sick, so we couldn't do it. So thank you so much for joining us. We will continue with our webinar series on Autosar next month. Yeah, and like I said, the next month, first Thursday, which is on
May 6th.
May 6th, we'll do a Lin stack webinar. Until then, thank you and have a pleasant month. Have a wonderful time.
Sure.
Thank you once again.
Thanks a lot. Bye.